Hi folks, today we're going to look at the last part of being able to factor a higher order polynomial. Remember that our goal this whole chapter has been to be able to factor them so that we can graph them and solve them. In the last day, we looked at how you could factor it if you knew one of the factors. You could use division to start to split it apart. The only remaining question is, how do we find those factors that get us started in the first place? And there's a cute little theorem that does that, called the integral zero theorem. We'll read it out here verbatim. If there exists an integer a such that x minus a is a factor of a polynomial, then a is a numerical factor of the constant term from the polynomial. So the integral zero theorem helps us find zeros, or x-intercepts, or roots, that are integers. That means positive or negative numbers, or zero. And it looks complicated to read this section here, but all it's really telling us is that if we find a factor and it's an integer, it has to be a factor of this final term, or this constant term in the polynomial. So let's think, what are the factors of 3? Well, 3 is pretty easy. There's just 1 and 3. Now, one thing that we should note here is that 1 could be negative or positive, and 3 could be negative or positive. So those are all the integer factors of 3, because 1 times 3 makes 3, and negative 1 times negative 3 makes 3. Once we've done that, we just chip away and try and guess and find one. So here's my polynomial right here. And I'm just going to sum in those numbers until I find a factor. I don't have to do them all, just until I find a factor. So if I sum in 1, I'd have 2 times 1 cubed minus 5 times 1 squared minus 4 times 1 plus 3. And what I'm wondering, is that going to give me 0? If I get a 0, then I've found a factor. Okay, because this is telling us the remainder. And if I work this all through, I'll get negative 4. I'll get not 0. That's the main thing. So x minus 1 isn't a factor. Okay, let's just try another one then, and hopefully something will crop up for us. So I'll have negative 1 cubed minus 5 times negative 1 squared minus 4 times negative 1 plus 3. So I want to go through this carefully here. That's going to be negative 2 minus 5 plus 4 plus 3. Oh my gosh, we got 0. And because it came from a minus 1 here, that means that x plus 1 is a factor. Yay! That's going to help us factor the whole big ugly polynomial. Now, I can do this division, which is the next thing I'm going to do, either synthetically or by long division. I'm going to show it with long division, though I'd probably be inclined to do it with synthetic division. So 2x cubed minus 5x squared minus 4x plus 3. And so I'd go ahead and divide out. So 2x cubed divided by x is 2x squared. Multiply them back in, you get 2x cubed plus 2x squared. Okay. Subtract off. And I am never going to insist on which way you do your division. So if you want to do this synthetically, great. All right, so negative 7x squared divided by x is going to give us negative 7x. And I'll multiply back in. And I'll carefully subtract here. So that's actually negative 4x plus 7x, which is going to give us 3x plus 3. Okay, I divide out. I get this 3, multiply back in, and just like I expected, remainder of 0. If instead you're doing this synthetically, here's how we're going to set it up. We're going to put the minus 1 here. Okay, if it's x plus 1, we're talking about the number minus 1. Put these little reminders, plus and times. And then I just put my coefficients over here in a row. Okay. And I pull this 2 down, I get 2. Then I go negative 1 times 2. Oh, that's negative 2. Add them up. Negative 1 times negative 7 is going to give me 7. 3, negative 3. My remainder is 0. Okay. What we learn from this is that if we partially factor 2x cubed minus 5x squared minus 4x plus 3, we are going to get x plus 1 and then whatever's left over here, the 2x squared minus 7x plus 3, okay, which is represented by these numbers in synthetic division. And once you've factored a bit, you try and factor some more. Now, we could go through the same process of factor theorem, but this 2x squared minus 7x plus 3 is just a quadratic, so we might as well factor it however you want, whether you're a guess and tester, whether you use decomposition. Let's see what's going to happen here. I'll have 2x minus 3 there, and I'll have a minus 1 here. Okay, that's going to get us our completely factored form. And you could double check it by multiplying it all out, but that does seem a little bit painful. Okay, so what did it ask us to do? Factor fully? Bam. We did it. How did we do it? We tested for some factors. Then once we found one, we divided. So here's another one. You can try the same thing on it. You could pause the video and just check it out. And I'm going to assume you did that, and so let's go through the process. I say, oh, there are possible factors here of plus or minus 3, plus or minus 1. I'm just going to hunt one down, and I'm going to start with the easy one. If I put in 1, I'll have 1 cubed minus 3 times 1 squared minus 1 plus 3. Oh my gosh, that's 0. So that means that x minus 1 is a factor. And I'm going to write that down every time, that is the factor that I found by plugging in 1. Okay. And now we can do this division. I'm going to assume most people are doing it synthetically. Okay, so I'd put a 1 here, a plus and a times, and the coefficients 1, negative 3, negative 1, and 3. Pull my numbers down, add, multiply and add, multiply and, oh my gosh, there we go. So what we found is that this whole polynomial here is equal to the factor that we divided out, and then the leftovers of x squared, 1x squared, minus 2x minus 3, right? This negative 3 would be the constant, this would be the x term, this would be the x squared term. And from there, we just factor some more. This is a short trinomial, so we're looking for numbers that add to negative 2, multiply to negative 3. Those would be x minus 3 and x plus 1. That's one sort of order to factor this in. Now, you might have done it differently. You might have found your first factor to be the x plus 1 by subbing in negative 1. Or you might have found it to be 3 by subbing in positive 3 there. I think it's always easiest to start with 1, but it's up to you. Your journey to this final answer may look a little different, but the final result should be the same regardless of which one you found or which factor you find first. So at this point, I'd be inclined to take a little break and look at page 134, 6ABC, just to get some practice factoring. And here we go with the last piece of the puzzle. Factor theorem, the last little bit, is to always remove common factors first. Listen, the first kind of factoring that we ever learned was greatest common factor. This stuff that we're learning now does not replace the other factoring that we know about. It's just what we do when we're out of options. So if I were asked to factor this one over here, I'd think first of all, are there common factors? There weren't in any of the other examples that we did, but there is here. There's a greatest common factor of either 2 or negative 2. And your life is going to be easier if you take out the negatives. So we'd have negative, then we just have in the brackets x cubed, we'd have minus 3x, we'd have minus 2. So I would have done some factoring right off the top. The nice thing about doing this is that it makes the rest of the question easier, because now this becomes your polynomial that you care about factoring. Okay, so we need to think about the factors of its constant term. That's our p of x. And I'll just sub numbers into that. If I put 1 in, I'll get 1 cubed minus 3 times 1 minus 2. I can already tell there's going to be more negatives than positives. That didn't work, so we didn't find a factor. That's fine. Let's just try another one. I'll put in -1. That'll give me 3 times -1 minus 2. Okay, let's think about that. That's -1 plus 3 minus 2 gives us 0. So x plus 1 is a factor. Yay! At that point, you'd start dividing. And so, just to be clear about the kind of division we're doing here, we're dividing the polynomial that we've got, the x cubed plus 6x plus 4. We're dividing it by x plus 1. Remember that you need a placeholder for every power of x. So if you want to do that as a long division, you can. I'm not going to see it all the way through with long division. Instead, I'll do synthetic over here. But same idea. We're going to have to put the -1 here because we're dividing by x plus 1. And we'd have, there's 1x cubed, there's 0x squareds, there's -3x's, there's -2. It's easier to forget the placeholders in your synthetic division. We pull this down, we multiply, add them up. And if you're having trouble with synthetic division or long division, there are lessons on those earlier in the chapter. And so what we learn now is that this can be factored into, I'll go for a new color, the -2 stays, we found a factor of x plus 1, and our leftovers are x squared minus x minus 2. And then we just keep factoring. So this will be x, let's see, add to -1, multiply to -2, x minus 2, x plus 1. Now, we've got a doubled bracket here, so it would be more elegant to write this as x plus 1 squared. And it will be important to do that later on when we go ahead and we start to graph them. But the process was hunt down a factor. I guess first of all, look for a GCF, then hunt down a factor, and then divide and factor until you cannot factor anymore. That brings us to factoring higher order polynomials, so stuff that's bigger than a cubic. So here we'd have to think of all the factors of -12. Now this one does not have a greatest common factor, so we don't have to take that out. Factors of 12 are 1, 2, 3, 4, 6, and 12. And sometimes people despair here and go, oh my gosh, that's so many things to check. No, you just need to check until you find one that works. And 1 is the easiest number to put in. Really, you'll just have your coefficients. 1 to the 4 is 1. 6 times 1 cubed is 6. 9 times 1 squared is 9. Minus 4 times 1, minus 12. Let's see. Oh my gosh. Equals 0. Just like that. We found one. X minus 1 is a factor. Okay, so we find a factor, then we divide. Okay, so I'm going to put that 1 in. And the coefficients are 1, 6, 9, -4, and -12. And I'll just go through the process. Bring it down, multiply, add them up, multiply, add them up, multiply, add them up, multiply, add them up. So this last little bit, the 0 is your remainder. It gives you some confidence that you have actually found a factor. So what does that mean? That means that we've factored this into x minus 1, that was the factor we found, with leftovers of x cubed plus 7x squared plus 16x plus 12. All right, so we can go ahead and do the same thing. We just have to repeat the process. It's not twice as hard, but it is twice as long. So the factors of 12 are plus or minus 1, plus or minus 2. The same ones we already had. Don't need to necessarily write these all out again. We know them. And you just keep chipping away until you find it for this new polynomial. This is the one you care about factoring now. Now, a keen eye would say, they're all positive in this, so no positive x values are going to give us 0. So that's not going to help. I could try p of 1, but it's not going to work. It's not going to be 0. I could put in negative 1. That would be negative 1 cubed plus 7 times negative 1 squared plus 16 times negative 1 plus 12. Let's see if this works. That's negative 1 plus 7 minus 16 plus 12. Oh, so close. So that didn't work. We can go ahead and try something else. And maybe you want to pause the video and try and find one at this point. And I found one when I subbed in negative 2. Okay, so because I subbed in negative 2, x plus 2 is a factor. So when it's in the binomial, it's the opposite of when it's just there as a number. Same sort of idea for the division. When it's just a number, I make it negative 2. Okay, and the coefficients from up here are 1, 7, 16, 12. Bring it down, multiply. Add them up, multiply. Add them up, multiply. Oh, this is so great. We got a remainder of 0. So now we know this factors further as x minus 1, x plus 2, the factors we found, plus the leftovers of x squared plus 5x plus 6. And we're going to keep factoring it. That'll give us x plus 2 by x plus 3, factoring that little quadratic. We have x minus 2 all squared in this one because it's doubled. So that's how we factor a higher order polynomial. We just go through the process twice. We hunt down a factor, we divide, and then we hunt down another factor and divide again. Okay, here's a sneaky one. I'll give you a second to think about it. What sometimes will happen is people will put a plus 0 here, and that's fine. The problem is that 0 has infinitely many factors. 0 times 1 makes 0, 0 times 2 makes 0, 0 times 3 makes 0, 0 times negative a million makes 0. That's not helpful. The reason I put this one in here is just to remind you that you should always be looking for a GCF first. Okay. If you can avoid doing this fancy factor theorem stuff, you probably should. And this one has the greatest common factor of x. So we get x squared plus 7x plus 10. Oh my gosh, that's just a quadratic. We can factor that. So at this point, we're able to factor any of the at least integer factorable questions. If you haven't already done them, head to page 134 and do numbers 5 and 6. Some of them will not factor all the way. You'll get it down to a quadratic and it won't go any further. And there may be one that's not factorable at all. If you go through all the possibilities and you don't find an integer factor, then you're done. It's not factorable, at least not in a sort of reasonable sense. So that's some practice work to do there. I hope this has been helpful, and good luck with the material, folks.